when we look at a formula like this, or when we look at a problem like this, we have to look and see what kind of circuit this is. Is this one loop or is this multiple loops? It's only one loop. Now, is it a simple circuit or is it a complex circuit? Why is it a complex circuit? There's two resistors on this circuit, therefore, this circuit is series or parallel? It is series, because how many loops do we have here? We've got one continuous loop the whole way around. So that makes it a series circuit. Okay? And in order to understand a series circuit or to work out problems in a series circuit, you need to understand Kirchhoff's laws. Okay? Before we actually get to those, you always start by writing down your givens. So what am I given in this problem?
R1 equals 6 ohms.
R1 is 6 ohms. R2 is 4 ohms. My total voltage is 40 volts. How do I know that this is total voltage? Because it's on the power supply. Okay? If I had put my voltage on this guy here, that would not be total voltage. Okay? So you need to understand where things are on the circuit here in order to figure this problem out. Now, what do Kirchhoff's laws tell us about voltage in a series circuit? VT equals V1 plus V2. What does Kirchhoff's laws tell us about current intensity in a series circuit? Now, what happens to total resistance in a series circuit?
RT?
What is RT here?
Total resistance.
Yeah, but what is it in this circuit?
R1 plus R2.
It's going to be the sum of all the resistors. You have a question like this in your analysis of your series lab. Okay, and you just have to sum up all of the resistors to get your total resistance. Now, if I know these formulas, then I can solve what I'm actually looking for. And this question is asking for what the voltage is across the second resistor. In other words, what is V2? So ultimately, we're getting to this formula right here. Okay, but we've got to use the other two to get there. So if I look at this, I'm just going to make this a little bit smaller so I've got room to work. So if I look at this, what do I know about getting my current intensity? What formula can I use with the values that I have to get my current intensity?
E times I.
V is equal to IR. That is Ohm's law. It's the only formula with resistance in it. And luckily, this is going to give us our I total, because we're going to use this and we're going to say V total, which we have, is going to be equal to I total plus R total, which we have. Okay? So if I want to isolate my I, what do I have to get rid of on that side? So I've got to get rid of RT over here. And if I do it on one side of my equation, I have to do it on the other. Okay, RT. So if I look at this now, I've got IT is going to be equal to VT over RT. What are my numbers?
40.
Going to be equal to 40V divided by
10 ohms.
10 ohms. So what does that give me for my I total?
4A.
It gives me 4 amps. Okay? Now, if I go back up to my Kirchhoff's laws equations right here, if I know I total, I then know I1 and I know I2, right? If I have my V total, I know that whatever this is, summed together is going to be equal to V total. And I know my individual resistances. So now what I have to do is I've got to break this up. If I go back down to my image here, I'm going to erase the power supply. If I'm pretending that this is my little circuit that I'm actually doing here, I'm going to erase the voltage off the power supply, and I'm going to move my voltage to this guy and to this guy, one at a time, right? Voltage, voltage. And that's going to give me a reading, right? Yeah. Now, math-wise, I can calculate what that's going to be because I have now, all right, I have 2 of my 3 variables. I've got V1, which I don't know, is going to be equal to I total times R1. Why I total?
Because I total is the same thing as
It's
I
the same
want.
thing.
Because I's are the same in a series circuit. They don't change. And if you don't know what that means, look at your data from your lab. Okay, the I1, the I2, and the I, every time you move the ammeter in your combined circuit, it gave you the same number. Okay? So what is my I total?
4 amps.
4 amps. So I've got 4 amps here, and what is my R1? 6 ohms. If I multiply those out, what do I get? What? 24. So I've got 24 of my 40 volts going to the first resistor. Okay? If I do this all over again, and I mean, I just did this because I'm going to go back to it to proof my work. But if you really wanted to be lazy, you could have just skipped right to the R2. Right? You didn't have to really do R1. I'm just going to prove to you that it works. So here, if I go V2 is equal to I total times R2, what is my R2? Okay, what is my I?
4 amps.
4 amps times 4 ohms. That gives me 16 volts. Now, if I sum these two numbers up, 24 plus 16 is 40 volts. So the answer to this question, okay, when it says, what is the voltage going across resistor 2, how much of the voltage does resistor 2 take from that pi? It takes 16 volts from the 40 volt pi.